The standard equation of a circle. Let xy represent any point on a circle with center hk and radius r. By the Pythagorean theorem, x minus h squared plus y minus k squared equals r squared. This is the standard equation of a circle with center hk and radius r. In example 1 to 4, write the standard equation of the circle. Alright, so first thing I'm going to do is write that equation. X minus h squared plus y minus k squared is equal to r squared, where h and k are the center of the circle and r is the radius. So the center of this circle is going to be 0, 0. My radius is going to be 4. So this is going to be x minus 0 squared plus y minus 0 squared is equal to 4 squared. I can clean this up a bit and just leave it x squared plus y squared is equal to 16. Oops, I just realized this little 4 right here, that means they're counting by 2's. So I almost made a mistake, but I caught it. Alright, that means my radius is 8, and so let's fix this up a little bit. That's 8 squared, which is 64. Okay, so lesson learned is check your scale on your axes. Alright, let's take a look at this next example. My center is right here. That means my HK is 2, 2. Let's see what the radius is. Okay, so now I'm checking out my axis. 0, 1, 2. This is scaled with 1, so I can just count across. 1, 2, 3, 4. My radius is 4. X minus h squared plus y minus k squared is equal to r squared. And this time, the only thing I can really clean up is the radius. In problem number 3, I don't have a diagram, but I have a description. A circle with center 0, 0. This is my h, this is my k. My radius is 1/3. So I'm going to have x minus 0 squared plus y minus 0 squared is equal to 1/3 quantity squared. Clean it up just a bit. And now I'm done. Number 4, a circle with center -3, -5. This is my HK and this is my R. Alright, so just be careful with this because we're going to have double negatives. Alright, these double negatives are going to go to positive. So x plus 3 squared plus y plus 5 squared is equal to 64. In problem number 5, it says use the given information to write the standard equation of the circle. The center is 0, 0, and a point on the circle is 4, -3. Okay, so let's think about this. My center is here, and a point on the circle is 4, -3. What I need to do is I know that my circle is going to go around something like this. What I need to do is figure out what is the radius from here to here. Let's go ahead and use our distance formula to figure out what this radius is. Okay, so the distance formula, if we recall from, goodness, back in Unit 1, x2 minus x1 squared plus y2 minus y1 squared. All right, let's label x1, y1, x2, y2. The distance between these two will equal my radius. So if I substitute this in, my second x is 4 minus my first x is 0. My second y is -3 minus my first y is 0. 4 minus 0 squared is going to give me 16. -3 squared is 9. And when I add those together, you get 25. So I know that my radius is going to be 5. So if I want to write my equation of my circle, that is going to be x minus, let me clean this up, try again, x minus h squared plus y minus k squared is equal to r squared. So x squared plus y squared is equal to 25. Okay, in the next example, the center is 4, 5. 1, 2, 3, 4. So here's my center. This is my HK. And a point on the circle is 0, 8. Okay, so I know that my circle is going to come around like this. I need to find this distance. That'll be my radius. All right, so I'm going to go ahead and label x1, y1, x2, y2. Let's plug it into our distance formula. Second x minus the first x squared plus second y minus the first y squared. So let's see, that's going to give me negative 4 squared, which is 16. 8 minus 5 is 3 squared is 9. Again, I'm going to get the square root of 25, which is 5. So this time, my circle, x minus 4 squared plus y minus 5 squared is equal to 5 squared. And this is going to give me, well, the only thing I can clean up here is squaring that 5. And now we're done. In problem number 7, find the center and the radius of the circle. So let's go ahead and just draw this. I want you to notice in this first one, my center is 0, 0. 49 is equal to r squared, so my radius is equal to 7. So my center is 0, 0, and 1, 2, 3, 4, 5, 6, 7. This is a circle that looks approximately like this. All right, so in problem number 8, this is my h and this is my k. So my center is 3, negative 2, and my radius is, well, this is equal to r squared, so my r is equal to 4. 3, negative 2 with a radius of 4. From the center, mark 4, up, down, left, and right. And then draw a smooth curve through those points. In problem number 9, let's see, my center is going to be the opposite of what's inside. So my center is negative 1, negative 2, and my radius, well, this is equal to r squared, so r is equal to 3. Here's my center, my radius, and here's my circle. And number 10, the center is going to be the opposite of what's inside, so 5, negative 4, and this is equal to r squared, so r is equal to 2. Here's my little circle. Last two problems. The point negative 4, 4 lies on the circle centered at the origin with a radius of 6. So let's see, prove or disprove the statement. Okay, so let's just think about this. If I were to draw a quick sketch, negative 4, 4, this would be this point right here. And it tells you that the centered at the origin, so this would be my center, my circle would go something like this. Is the radius 6? Well, I need to figure out what the distance is between these two. I'll use my distance formula. x2 minus x1 squared plus y2 minus y1 squared. Okay, so this is my x1, y1, centered at the origin, well that's 0, 0. I'll call this my x2, y2. So now let's plug this in, and if it equals 6, then I will prove it. If it doesn't, then I'll disprove it. So my x2 minus my x1 squared plus my y2 minus my y1 squared. Double negative makes positive 4, so that's going to give me 16 plus 16 the square root of 32 is not 6. So I'm going to disprove this. This is not correct. Number 12, the point negative 1, 2. So let's again start with a picture. Negative 1, 2. That's right here. Lies in the circle centered at negative 4, negative 1. Okay, so here's my center. That means my circle is going to look something like that, approximately. Is the radius 3 roots 2? I've got to figure out, is this distance here 3 roots 2? Just like we did before, let's start with labeling our points. Plug it into the distance formula. x2 minus x1 squared, y2 minus y1 squared. So let's see, double negative makes that positive. Negative 4 plus 1 is negative 3 squared. That gives you 9. And this is negative 3 squared, which is 9. And so this is the square root of 18. Let's do a factor tree on 18. 2 and 9, 3 and 3. If you have a pair, you go out. This is 3 roots 2. So